Okay, hello and welcome to this video talking about similar triangles with a couple of special cases thrown in which often confuse. But before we get going, I'm going to start defining what makes two triangles similar. Now, any two shapes are similar when they share share the same interior angle. So in triangles cases, that would be three angles which are exactly the same. It doesn't matter if the triangle has been shrunken or enlarged. You could say that a shrink is an enlargement with a scale factor smaller than 1. So this is similar to our original triangle here. You can rotate them, or you could even reflect. Okay, so as you can see, our angle in the bottom left, I don't know what that arrow is doing there, our angle in the bottom left is not the same as it was before. Okay, so I've labelled these with colours just so that you can see the rotation, but we could also start labelling them with some numbers. So let's say we've got, in fact, let's keep the colours there as well. But let's say we've got a 50, a 60 and a 70 degree angle within our triangle. Okay, you can probably tell that actually you don't need all three of these angles, do you, to show two things are similar. If we've got 60 and 70 degrees here, then this missing angle has to be 50 degrees. So any two triangles we can say are similar if they just share two of the same angles. Okay, because no matter what, this final angle has to be the same. Okay, and in fact we can go one step further. If I have a look at this bottom triangle, if I get rid of our purple angle, so I'm just left with 60 degrees and our yellow was 50 degrees, then this missing angle has to be 70, and therefore it is shared with our original triangle to start off with. Okay, so as long as they have the same interior angles, we can say that they're similar. And generally speaking, we only need two angles to be the same for that to happen, because we can always then work out what the third would be. So let's have a look at a couple of special cases. Now, it might not look like we have two similar triangles here, but the fact that we've got parallel lines is vital. If I start colouring in some of these angles again, so let's say that we've got, this is a pink angle, this is a yellow angle, and this is an orange angle down in the bottom right. Then we do have two triangles here. We've got this smaller triangle at the top, and we've got this larger triangle overall. Now they do look similar, but can you think how we can prove that they're similar? Yes, because we've got parallel lines, we can say this angle here is corresponding to our yellow angle. We've got that F shape. And similarly, the orange angle corresponds to this orange angle at the top. Now, whenever I do these questions, let's go back to blue, I always like to draw the triangles out next to each other so I can see what I'm dealing with. I find it makes the question a lot easier if you've got two triangles next to each other rather than one inside, and you can compare what's what much more easily when you've got two triangles next to each other. So we'd have a pink angle at the top for both of them, and we'd have a yellow angle in the bottom left for both of them. Okay, so that's example number one. Now, a second sort of example, again with parallel lines, because we're going to be using the parallel lines rules here, are these two triangles. So to start off with, if I label this angle in the middle, I hope that you can see that the angle vertically opposite it will also be pink. It will be the same size. But what about these other angles? Well, hopefully you can see a little bit clearer if I get rid of one of these lines. So if I label this angle at the top orange, and we could also say this angle at the bottom left is also orange because they are alternate angles, and alternate angles are the same. Okay, Now this is a common mistake that people sometimes make. They often think that because this angle is on the right, it must be the same as this angle on the right. But you need to be very careful here. It's sort of rotated this shape. I'll show you an even more extreme example later on. Okay, but that angle at the bottom right is not orange. This angle at the bottom left will have to be. And for a similar reason, we've got a yellow angle in those two places. Again, you don't actually need that yellow angle to show that they're similar, because we have two angles which are the same. But it's nice to fill in the gaps as well and sort of say that we could do it independently if we wanted to. Now, this smaller triangle, again, whenever I've done this, I always like to draw them out side by side. It sort of looks right-angle-y, maybe not quite a right angle. We could say that this is our smaller angle, smaller triangle even. Okay, and it's quite easy to just mentally rotate this one so we can see what's going on. Our larger triangle though, we're sort of rotating quite a bit to get the orientation the same size. Okay, so again I'm just going to pinch that in a little bit. And we would have the pink angle at the top, we'd have the same orientation, the orange angle bottom left, and we'd have the yellow angle bottom right. Now it's important to remember when we're comparing two similar triangles that the corresponding sides are the sides between the same two angles. So if they'd been reflected, for example, like in this starting question, this side over here would correspond to this side over here, because that's between the orange and the purple angles. Okay, so that's what we're looking for in this example. This length here would correspond not to the side next to it, but sort of the one opposite it on the other side of the vertical angles. Okay, and that's again another very common mistake that people make. They often just pair them up with whatever's closest, but that would be wrong. Okay, right, let's have a look at a couple of quick examples. So we've got two similar shapes. I hope you can see that, and this is the more extreme example I was talking about earlier. You can see that the yellow angle is obtuse and the orange angle is acute. So you can see again you've got an obtuse angle here and an obtuse angle here, so they have to both match really. But as always, before I get into this question, I'm just going to draw out what both of these look like. Well, let's try that again. Okay, there's our smaller one. I need to commit. There we go. And we can stretch it out this way. Now, I've already color-coded this for us. So we've got a pink angle at the top, and therefore this will have to also be pink. Orange in the bottom left, and yellow in the bottom right. You don't have to do this, I just find it helps me orientate myself with which angles correspond to which angles. So we've got between the pink and the orange we've got 4 for the small one, and between the pink and the yellow we've got 3, and we have Y between the orange and the yellow. Between the orange and the yellow for the larger one we have 8. Between the orange and the pink we've got 10, and between the pink and the yellow we have X. Okay, so if I just gave you this question in isolation, away from the starting question, let's hide it from sight, this would be fairly straightforward. And this is why I always like to draw the triangles out separately away from our starting problem. So we need to first work out the scale factor. What am I timesing by to get from the smaller to the larger one? And we can work this out by doing the larger length divided by the smaller length, 10 over 4, which is 5 over 2 if we simplify it, or 2.5. Okay, so I can say I'm timesing by 2.5 to get to my larger triangle, and therefore I can work out x. X is going to be 3 times 2.5. Okay, if I type that in on my calculator, 3 times 2.5, I get 7.5. Now to go the other way, I'll need to divide by 2.5. So y is going to equal 8 divided by 2.5. So let's type that in on my calculator. 8 divided by 2.5 is 3.2. Okay. Okay, let's move on to our next example. Now we've got a lot going on here. Oops, this needs to say y, I think. We are being asked to find the perimeter of the parallelogram ABDE. Okay, so that's this parallelogram here. It should really say ABED, or I should have labelled this slightly differently because otherwise it does this zigzaggy thing, but you get what I mean. We've got some things measured, we've got some things which haven't been measured. I think, as always, the best approach to do is to just draw out these two triangles separately. Okay, we've got a larger one and we have a smaller one. Now it's given us letters to use with this one, so it might help us to copy those letters down as well. We've got C, C, A and B. Okay, and again I've colour-coded the larger one, but we can also carry this across to our smaller triangle. Okay, and orange in the bottom right hand corner. Okay, now what measurements are we given in this question? Well, we're told that this length is 6. Okay, that's our length between D and C, between the yellow angle here and the orange angle in the bottom right hand corner, and we also know between the pink and the orange is a length of 7. Ooh, it's a very pink 7. Okay, now what is the length of A to C? Now we need to be a little bit careful here because it's not this length. It's not the length between the yellow angle and its corresponding yellow angle. It's actually the whole length of this from A to C, which is 12 add 6, so 18. Okay, we know that A to B from above is 15. We don't really know much more than that though. Okay, so we need to work out the length of x, which is sort of halfway along here. It might not be halfway along, there's going to be a distance along there, and we also need to work out this length from D to E, because that will give us our full perimeter. It might be easier to work out y first. Okay, but as always, I'm now going to just sort of block out the triangle I had at the top. In fact, what I might even do is just move these down a little bit, give myself a little bit more space, so I'm only focused on these triangles. So again, I'm going to have a look at my scale factor between the two shapes. So these two sides are corresponding. I can work out the scale factor by doing the longer side divided by the smaller side, 18 divided by 6, which is 3. Okay, so to work out D to E, I can do 15 divided by 3, which is 5. And I think that was our value for y. Let's just have a look. Yeah, it was our value of y. I don't know what's happened to y there. Right. Okay. Now we can also work out this length here, the whole length, which isn't x, but it might help us work out x. Okay, I can do 7 times 3, which is 21. Okay, so we know that that length's 21, and we can actually now use that to work out x. If I know the whole length is 21, and I've got a length of 7 here. 21 minus 7 is 14, so this length has to be 14. I previously worked out that y was 5, so the total perimeter, which was my question if you remember, is going to be 15, add 14, add 5, add 12, 15, add 14, add 5, add 12, which is going to be, I think, 46, I think. Let's just check that on the calculator. 15, add 14, add 5, add 12, which is 46. I'm going to lock that in as my answer. Now, I haven't used units in these questions,